And so we're going to start our study of trigonometric functions by focusing on trig functions for first quadrant angles. And what we mean by a first quadrant angle is, first, it has to be an angle drawn in standard position, meaning we always start at the positive x-axis, so down here along the bottom, and then we measure up counterclockwise. And if it's a first quadrant angle, that means that the terminal side, this side over here, ends up in the first quadrant. So a first quadrant angle is between 0 and 90 degrees. Now, this terminal side, right, we could draw it, you know, as long as we want, right? It could go on forever, really. But what we do is we just pick a point that's on the terminal side. Here, I've picked the arbitrary point here that I'm calling, you know, it has x coordinate x and y coordinate y. It doesn't really matter how far up you go. You just pick a point. And then you drop down a perpendicular, as we've done here. And when you do that, the length along the bottom is equal to the x coordinate. And the vertical length is equal to the y coordinate. The hypotenuse, which is the long slanty side, we always refer to that as r when we're doing stuff with trigonometry. So we have a nice right triangle, right? Because we drop down that perpendicular. And once we have picked a point and dropped down the perpendicular like this, and we have these measurements, we define the trig functions as follows. Now I'm going to focus first on the left column. We have the sine, cosine, and tangent functions. The sine is defined to be y over r, which is equal to opposite over hypotenuse. Now, opposite, the words opposite and adjacent are in reference to the angle. So opposite meaning across from. So that's an opposite. Adjacent means next to. So this is adjacent. You might look at this and say, well, isn't the hypotenuse also adjacent? And yes, that's true, but the hypotenuse has its own special name, so opposite and adjacent are always chosen between the two, what we call the legs, those perpendicular shorter sides of the right triangle. So the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse, so we take the x-coordinate over r. And tangent of theta is opposite over adjacent. So the functions in this left column we can remember with the mnemonic device here, SOHCAHTOA. So this just reminds us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. For the three functions on the right, these are simply reciprocals. So the reciprocal of sine is cosecant. So cosecant theta, you just flip over the fraction. So it's r divided by y. The reciprocal of cosine is secant. So secant of theta is r over x. And the reciprocal of tangent is cotangent. So cotan theta is x over y. In addition to these 6 functions, and how they're defined, we'll also find it useful to invoke the Pythagorean Theorem. And the Pythagorean Theorem you've probably heard a million times, but it simply says that in a right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. So if we've labeled the sides of a right triangle A, B, and C, where C is the hypotenuse, the Pythagorean Theorem says that this equation holds in a right triangle. We're going to do a couple of examples. First, we're going to find the values of the 6 trig functions for the angle theta with terminal side passing through the point 815. Well, the first thing I'm going to do is just kind of sketch out that angle. So it's passing through the point 815. These are first quadrant angles, so in fact, actually, if you bear with me here, I'm going to redraw, because since it's a first quadrant angle, I really don't need to show the other quadrants. So 815. Here's my angle theta. And we want to find the values of the 6 trig functions. So they've given us some measurements. So the first thing I'm going to do, drop down this perpendicular. I want to draw that triangle, the right triangle. So the length along the bottom here is 8. This length here is 15. And we need to know the value of the hypotenuse, and we can use Pythagoras to help us find that. So Pythagoras says that 8 squared plus 15 squared is equal to r squared. And if I know what r squared is, then to find r, we're going to take the square root. Now some folks like to find 8 squared plus 15 squared first and then take the square root. But you can actually do the whole thing in one go. So on the calculator here, I'm going to open up a square root, and then 8 squared plus 15 squared. You'll notice it's all underneath the radical sign, and that gives us 17. Now I'm going to show you, and if you have an older version of the OS on your calculator, it might look a little bit different, and you're going to maybe need to use some parentheses. So I'm going to show you what that might look like here. So if I've taken the square root, again, I'm going to use the same keys, second square root sign. And notice now it just opened up parentheses, so I have 8 squared plus 15 squared, but it doesn't show the top of the radical extending over. I actually have to close those parentheses to tell my calculator that that whole thing is inside the radical, and then I get 17. So r is equal to 17, and now we can find the values of the 6 trig functions. So I'm going to start with sine theta, cosine theta, tan theta. And for sine, this is opposite over hypotenuse. So that's 15 over 17. For cosine theta, adjacent over hypotenuse is 8 over 17. And tangent is opposite over adjacent, so that's 15 over 8. Now for the other ones, I'm just going to take their reciprocals. So cosecant theta is the reciprocal of sine, 17 over 15. Secant theta is the reciprocal of cosine, so 17 over 8. And cotan theta is the reciprocal of tangent, 8 over 15. And those are the values that we're looking for. Okay, let's try another. This one is given to us a little bit differently. Here they tell us the value of secant. And we know that theta is in the first quadrant. We want to find the values of tangent and cosine. Well, to start off, since they told us the value of secant theta, then we kind of get the value for cosine almost for free. So I'm just going to flip it over. 2 over root 5. Some of you might be asking right now, do we want to rationalize the denominator? If you don't know what that means yet, don't worry, we're going to get to it. I guess my answer to that question right now is you can if you want, but you don't have to. So you can leave it here as 2 over root 5, or if you want to rationalize the denominator, we can do so by multiplying the top and the bottom by root 5, and we get 2 root 5 over 5. I'm going to go ahead and use this form here to help me solve the rest of this problem. If I know the value of cosine, I can really think of that as knowing two sides of a right triangle. So theta is this first quadrant angle. It goes through, you know, it could go on forever, right? But it goes through, you know, some point here. I could drop down this perpendicular. And if I look at this right triangle, I know that this 2 over root 5, I can think of this as adjacent over hypotenuse, because that's how we find cosine in a right triangle. So I can label this bottom side here as 2, the hypotenuse is root 5. We don't know the opposite side yet, but we can find it, again, using Pythagoras. So Pythagoras says that 2 squared plus y squared equals root 5 squared. Remember that it's always the hypotenuse that's on the side by itself in the Pythagorean theorem. So 4 plus y squared equals 5. If you square the square root of 5, you get 5. And if we subtract 4 from both sides, we get y squared equals 1. And taking the square root, I don't even really need my calculator to do this one. The square root of 1 is 1, and I know I'm only looking for positive 1 because it's in the first quadrant here. It's the first quadrant measurement. So we know that y is equal to 1, and now we can use SOHCAHTOA to get the value of tangent. Tan theta, opposite over adjacent, is 1/2. And there's the other value they asked us for.